It's all good. Okay, so this is on page 114. We're doing the location principle. So this says if a function is a polynomial function and a and b are two real zeros, two real numbers, such that f of a is less than 1 and f of b is greater than 0. Sorry. Oh my gosh. I can't even speak now. F of a is less than 0, f of b is greater than 0. Then f has at least one real zero between a and b. So what this is saying then is that we plug in a value for a, and if that answer is less than 0, and we plug in a number b, and the answer for y is greater than 0, then we have to have a real zero in between it. That may not make sense when you look at it this way, but look at it this way. Let's say we have a table of values. We have x, f of x. Let's say we've got -3, -2, -1, 0, 1, 2. We get y values of, say, -5, -3, 1, 3, -2, -4. And we're trying to find out between which two integers would there be a real zero. Look at these y values. -5, -3, 1. What would have to happen in between here? We'd have to cross what? 0, right? Wouldn't there have to be a 0 in between here if I have a y value? Think about it, guys. I have a point -2, -3 right here. Then I have a point -1, 1. If I connect those dots, don't I have to have a 0 in between there? See what I'm saying? So right here, between -2 and -1, we would have to have a 0. Where else do we have to have a 0 in between what? Between -1 and what? Really? Between 1 and 3? There's not going to be a 0 there. Between 0 and 1, right? Because we go from a y value of 3 to a y value of -2. Wouldn't there have to be a 0 there? See what I'm saying? So also between 0 and 1. All right, so what if I gave you this information? F of 2 is -3, f of 3 is -1, f of 4 is 2. And we want to find between which two integers would there be real zeros. Would there have to be a 0 between 2 and 3? Would there have to be a 0 between 3 and 4? Yeah. See, this is saying, guys, this is saying x, when x is 2, y is -3. So it's saying this. This is the y value when x is 2. That's what this notation means. This is saying when you plug in 2 for x, the answer is -3. When you plug in 3 for x, the answer is -1. When you plug in 4 for x, the answer is 2. Is it easier now to look at where the 0 has to be? What two x's are causing us? Between what two x's are we getting that 0? What is it, guys? Between, I hear people saying between 2 and 3 and 3 and 4. Which is it? Between 3 and 4. Because we go from a negative to a positive. See, look, if I plotted all these points, you could do this. I'm hoping you don't really have to, but at 2, I'm at -3. At 3, I'm at -1. At 4, I'm at 2. Connect the dots. See how I have to have a 0 right here in between 3 and 4, but not in between 2 and 3? Because to connect those dots, I don't have to pass through 0. Everybody with me there? All right. That's it for that section.
Wait, I have a question.
Yeah.
I got f of x stood for a y. So how does
It does. Look, you're right. F of x is the same as y. But what it's saying is, depending on what your x is, that's what your y is. So in this spot is always your x, and this is your y. When it says f of x, that is equal to y. So this is y, but this is x. See how there's the letter x there?
yeah. But like when you're in an equation, you write like f of x equals like x squared blah blah blah.
Right? So f of x equals x squared blah, blah, blah. Right there, right?
Yeah.
So now if I ask you what is f of 1, that means when x is 1, what is y?
Oh, so you do like 1 squared plus 1.
Right? And what is it?
2.
There you go. There's f of 1. So that's telling me I have the point 1, 2. Okay?
Thank you.
You're welcome.